Hello, this is Joris Peels. This is another episode of 3D Printing News Unpeeled, courtesy of 3dprint.com. So what we're going to try to do today is we're going to try and do a little bit different, and we're going to try and do it with some images on the side. So just trying to see if you guys want to do that. So I'm trying to figure that out now. So this is, again, your 3D Printing newscast, and we're going to bring 4 stories for you today. And these stories are all, well, kind of relevant or very relevant or very, very interesting or all of the above. So at the moment, we have 4 stories. And the first one is this story. And that is that Framework essentially is caving to Lenovo. So what's happening here is really relevant, I think, going forward for 3D printing. So Framework is a company that wants to make kind of reusable, upgradable, fixable consumer electronics. So their idea is you can take your own motherboard, make it into kind of a little mini PC, or use it as a part of a laptop, or you can gradually upgrade in a very easy way the hardware of things you need, and of course, you can 3D print components. So if something would break, you can print a new one. Or in this case, the casing of this little mini PC thing, you can 3D print as well. Which, of course, is very interesting. A lot of companies have tried to do this and failed with this. It's going to be very difficult for them to make it happen. But I think compared to a couple of years ago, the right to repair movement is much more prevalent, much more important. People are much more into like being ecologically friendly and sustainable generally. So this might be a right moment for Framework. Now, what happened is these guys, of course, are making PCs and peripherals at the moment. And they made this design, which you can see here on the top right. And that's a button. So what they wanted to do is 3D print a button. And then Lenovo wrote them, or lawyers acting on behalf of Lenovo, wrote them this letter. And they're talking about the unauthorized use of the design trademark. So this is really interesting that it's about a trademark, right? It's not saying that that is a patent infringement thing. It's not saying that there's some kind of functional thing there that they copied. But Lenovo had a Legion trademark. If you look at the trademark right now, you can see already that that logo is very, very close to this button. So the broken O design of the Framework thing. So if we go back to this component, yeah, this is kind of obvious. And, at first glance, at first blush, I'm going to totally have to give this to the guys at the Lenovo. This is like totally is their is so reminiscent of their logo, and they're using it in the PC business, and these guys are using it. So they don't really have much. Lenovo really, doesn't have much choice but to do something on this. So I think that's really interesting. But one thing that I think is relevant here is that how else would you make a button? There are other ways to do it, but how else would you make a button and still maintain one 3D print, one FDM 3D print? This is kind of a very logical design to do it. So I think as we move more into consumer electronics, as we move more into more kind of like consumer-oriented things, we may very well get that we're very certain design directions are blocked because of other people's trademarks or patents or other kind of content. So I thought this was very interesting and very something to think about, mull about. This is an earth-shattering story. Again, Lenovo isn't the baddie here because, like, if we look at the logo they have and the reminiscence of this physical object, which maybe isn't even intended to be a logo, they kind of had to do it. They don't have much of a choice. They have to use it or lose it in this case. So, so I think it's a good move by their point, let's say. Now, but I thought this was something interesting to consider, that other people could block very kind of prevalent design decisions with 3D printing, very, very things that we can print that we really need to print, shapes that we would need to print, and then block these so that we can't use them. So that could be something to consider. The next thing is a company called Azure, and this is the Azure 3D printed houses. There's a couple other 3D printing startups also called Azure or similar. But this is specifically an LA-based 3D printing houses startup. Now, what they're saying they do is they 3D print houses made at least 60% out of recycled polymer. They don't really specify what it is. I think it's PETG, but it could be anything really. And they 3D print these homes or parts of homes. It starts at about 16 square meters at about $20,000, and it goes all the way up to like nearly $190,000 for about 83 square meters. So, so generally, that's interesting, but we've seen that before, right? We've seen kind of houses like this before. What I like about this is what they're saying it's very highly recycled content, and they're making them in factories. So maybe to stop warp age and all this kind of stuff, they actually have a really, really big heated chamber. That could be very interesting. Or they're putting fibers in them. If they then say that stuff is recyclable or easy to recycle and sustainable, I'm guessing it's not e-glass or something. I'm guessing that should be sustainable as well. So that, I like the paradigm of printing houses in a factory. I like the idea of saying we're going to make them indoors in a controlled environment, and then we're going to ship them to people. Especially with polymer, that'll be very cheap to do. So I like that very much. What I also really like about the startup, and the reason they're here really, is the fact that, well, they're doing this, like you said, the example you see before you is kind of like a gym, right? So the idea is you want to print a little gym for your house. And they also have like more examples in a configurator, kind of like an outdoor studio, or more like a one-bedroom apartment, kind of mother-in-law type apartment kind of thing. And they do the same claims as everyone does, 70% cheaper, 30% faster, that kind of thing, all this. So it's pretty standard, right? But what's interesting is they're doing this in LA, right? And they're doing this with a very, very, very specific local purpose at the moment. Their go-to market is very, very local. Now, in LA, or in California, generally houses are very, very expensive. Now, there are certain parts of the country and the United States of America, this is a very particular thing there, that they want to have all the houses be single-family homes on one kind of plot with a garden. They don't want to let you convert them to apartments. They don't want you to put 2 or 3 houses on there. They just want everything to be kind of like your kind of suburban home. They think that they want to keep the home values high. They want to keep that area desirable. I think that cheaper dwellings is not going to make it more desirable, make it less desirable, make them get less property tax, right? Because they essentially get a lot of their funding, especially cool school funding, from property tax. So this unique thing is that they, on the one hand, these counties and these places realize that housing affordability is a huge problem, but they're not set up to split up these, and they're not willing to split up these single family homes into apartments or smaller dwellings. So what they have is a uniquely Californian thing, which is the accessory dwelling unit, or ADU. And an ADU is something that in California, it's relatively easy for you, compared to splitting the property. It's relatively easy for you to build kind of a mother-in-law apartment or an extra kind of home if it meets certain conditions on your property. And you could then subsequently, in some cases, rent it out or use it as a studio or use it for something. So specifically, that market is what Azure is really, really focusing on at the moment. And I love this idea of a really local, hyper-local kind of Californian real estate trend being their kind of focus. And I like them making these things for something. But imagine, for example, if you took all that expertise at one point and then you said, oh, wait, there's another opportunity in Finland where we can make summer houses for people under a new law or whatever. Then you can either translate that opportunity to a similar opportunity in a different place, or you could physically move your factory there and do this physical opportunity or part of your factory. Imagine this ADU boom is over and done with. It's a couple of years, and they sour on it. They don't do it anymore. Well, then you can go up, move the whole thing and go to, or move part of your production capacity to Finland, for example. So I love that idea of being able to have a hyper local offering. They could design these only for California. They could design them specifically for that market, or Fresno, or whatever area of California even. And could really change these designs and make them very granular. But at the same time, they could take that expertise and then translate it elsewhere. So I like that very much. Now, the second, the third page, point of news is, well, okay, you're going to kind of think this is really kind of boring, but it's a 3D printed smart vent. This is a vent made by Tony Brobston. And what Tony did is he took a Wi-Fi board and a servo motor and a Wi-Fi receiver and made this, connected this 3D printed vent design to MQTT, which is an IoT messaging kind of service. So you could check if the vent is open. You could manipulate the vent by opening or closing it. You can then kind of take this 3D printed vent and add it to your smart home infrastructure. I love this. I love this because, it's a maker project. You see a lot of things like this on Thingiverse. In this case, I decided to share it on GitHub. But we see a ton of stuff like this, right? But I'm specifically really interested in things like vents, light fixtures, plugs, all these kind of screens and commanders and displays we see emerging. Like, in a home that you can infinitely customize, these things are often very difficult to customize. And I like very much the idea of offering people the idea of customizing these things, making them theirs, having really unique vents for really unique homes, changing the way that works. And that I think is a considerable opportunity that has been super unexplored. And right now with FDM printers, we can get kind of close to where we need to be regulatory wise with this, or we can print in the materials that they often need. And we can get a lot of the the touch and feel and the beauty that they need as well. And at really low cost. So this could really be a customized or low volume or really unique vents or things like that. I think is really something that I'm not sure if it'll ever work, but I do know that we need to look more at it because it is a considerable opportunity for everyone to do this kind of light fixtures, AC vents, that kind of thing. So those are the top 3 news items. And the number 4 is 3D printing ice. Now, this actually was hilarious to me because years ago, I think in 2008 or 9 or something like that, like a really long time ago, I was working at Shapeways and I did a April Fool's thing, and that was 3D printed ice, right? I made lots of jokes about 3D printed ice. Here we are a couple of years later, and now I realize that actually the joke was on us because this is actually kind of brilliant. There's a CMU team that 3D printed ice, right? Now, what they're doing for 3D printing ice, and we did brainstorm about this afterwards when some of the people in the community did mention it. What they did is this. It's literally like if I ask you, like, let's 3D print ice, what would you do? And they took an inkjet nozzle, piezoelectric inkjet nozzle, and they put a cold, really cold, -35 C build platform, and they're printing on it. What they then do is they sync the XY motion build platform with the nozzle deposition, which is, of course, I would guess the tricky bit. And they can build free-forming ice structures. Now, first, this is really cute, but these things are really, really thin and really, really very fine channels, as you can see here. Of course, this already reminds you of something. I'll show you some pictures of what it looks like. Don't ignore the silly octopus, but you can already see what it looks like, and it's really, really thin channels. Now, why these guys did this, and the reason they think this is going to really have legs, and that was kind of a joke, and the reason is they think this is really going to have legs is the following. These really, really thin channels, they're you can pour resin into them or over them, and then you'll get a really thin channel kind of structure. And that could be a really ideal thing for microfluidics, right? And making things like lab on a chip and all these microfluidic things. I mean, water is really, really cheap. This could make really fine channels. They're a bit weird on the details, but so maybe we'll share those later if they become more available. But and then these fine channels will then be able to make a better microfluidic device. Or in tissue engineering, we have to have these veins and all these other little tiny structures of the body. These can be replaced by resin, and then these could be maybe even finer than a 3D print. So I think that's a really great piece of news. So thank you so much for being with us today. Thank you for enjoying this cast, and I hope you really enjoyed it and liked it, and enjoy the Joris effect as well. And yeah, tell us what you think of the images.